Okay, now start with chapter 5, which is talking about forces, density, and pressure. As we said before, we have many types of forces. We have the weight, which is acting on the object toward the center of the earth. This is the weight. It is because of the gravitational force. So this force, which is the weight, is non-contact force. No need for a contact between this object and this object to have the weight. Also, if we have a positive and a negative or positive charge, so we have attraction or repulsion depending on the charges. This is another type of force, which is non-contact force also. If we have north and south poles against each other, we have attraction force. This is a non-contact force. We have forces need to be a contact between the object and other object, like friction. If we have a driving force towards the left, we have friction. Friction is a contact force. So we have a contact forces and non-contact forces. Now, the weight of the body is an example of the force acting on a mass in what is called field of force. So it's act from a distance. This is a field of force. Like the electric field, we have electric field lines here. So this force can act on this object like this. There are other sorts of fields of forces. An important example is the electric field, as I mentioned before. We have also the viscosity or viscous force. This force according to motion of objects in a fluid like liquid or a gas. So if the object moving downward, we have a viscous force, okay? We have a viscous drag or viscous force against the object. Now, also we have an upthrust. Upthrust is a type of force. The reason for the upthrust is the difference in pressure in the upper part of the object and lower part of the object. Here, the pressure, depending on this h, this height, this is h1, pressure here is density by gravity multiplied by height 1. Pressure here in the lower point is density gravity h2. So the difference in pressure is density gravity multiplied by the difference in the heights. And according to the low pressure equal force over area, so the force equal the change in pressure multiplied by the area. We have another type of force produces a moment. If we have a force acting on the object perpendicularly and the object have a pivot here, so we have a rotational or a turning effect of the force. The turning effect of the force is a moment. Moment will allow the object to move in clockwise or in anti or counter clockwise depending on the force. What if the force is not perpendicular to the object? If the force acting by an angle from the rod, and this is the pivot. So we will take the component of the force acting perpendicularly. So this is the force sine angle, and this force parallel to the object is force cosine angle. The force which is parallel to the rod will not produce a moment, as the force acting on the pivot, it will not produce a moment. So to calculate the moment, what you need, the force multiplied by the distance between the pivot and the point of force acting multiplied by sine angle. if the angle given between the force and the rod, or multiplied by cosine the angle if the angle given is the angle between the force and perpendicular to the rod. The unit of the moment is a Newton multiplied by meter, okay? You have to remember that work, it's equal to force multiplied by distance, and moment equal force multiplied by distance, but this is the perpendicular distance. Okay, this is the first difference. The work measured in a Newton meter or a Newton centimeter, the moment also measured in a Newton meter or a Newton centimeter. In work, I can use unit joule instead of a Newton meter, but in moment, I can't use it, okay? The work is a scalar quantity, but moment is a vector quantity. Now, maybe sometimes we have more than one force acting on the object, so we have to calculate many moments like this. If we have pivot here and we have F1, F2, and let's say F3, and the distances given from here to here, let's say 2 meters, 1 meter between F1 and F2, and another 2 meters between the pivot and F1. So to calculate the moment, we have to calculate moment of force 1 and moment of force 3, both of these moments acting in the clockwise direction, but moment of F2 is in the anti-clockwise or counterclockwise. Let's say F1 equal 3 Newton and F3 2 Newton and F3, let's say 16 over 3 Newton. Now let's calculate the amount of moments. Moment of force 1 is 3 multiplied by 2, which is 6 Newton dot meter. Moment of force 3 is 2 multiplied by 2, 3, and 2, 5, which is 10 Newton meter. And both of these forces or moments acting in the same direction, so the total moment is 16 Newton meter in this direction. Now F2 is 16 over 3, so moment of force 3 is 16 over 3 multiplied by 3, which is 16 Newton dot meter. So both moments in a clockwise and in anti-clockwise have the same value, okay? So the object will not rotate, but I can't say that this object is equilibrium unless the total forces acting on the object upward equal the total forces acting on the object downward. So I have two conditions of equilibrium. If the total momentum total moment clockwise equal total moment anti-clockwise, and resultant force acting upward equal resultant force acting downward. Now, what is the couple? If I have two forces equal and opposite, two forces equal and opposite, and acting on the object, this is force 1, let's say 2 Newton, and this is force 2, also 2 Newton. So if I have two forces equal in magnitude, opposite in direction, and parallel, and not acting on the same line. You see, we have here two lines, okay? Two forces equal, parallel, not on the same line, okay? So we have a couple. The object will rotate in this direction, like when someone drive his car, okay, he act by two forces equal and opposite. Another example of couple, when you open the water using this tap, you act by two forces equal in magnitude and opposite in direction. So we have a couple, okay? Another example also, when you open the door using the key, you act by two forces. These forces are equal and opposite, force from here and the other from other side. Okay, the two forces are equal, 2 Newton, let's say, and we have to take the distance between the two forces. So to calculate the moment of the couple, we take one of the forces. Both of these are the same, so I have to take one of the forces multiplied by perpendicular distance between the two forces. Okay, again, here 2 Newton and 2 Newton. I have to take one of the forces multiplied by the distance. If there's an angle here, I take 2d cosine angle, or sorry, force multiplied by distance by the cosine, the angle. So the torque of couple is the product of one of the forces and perpendicular distance between the forces. To have equilibrium of the forces, I said the resultant force have to be 0 and total moment equals 0. The principle of moment states that. This is an important question. What is the principle of moment? It states that for a body to be in rotational equilibrium, the sum of a clockwise moment must equal the sum of anti-clockwise moments about a same point or about a pivot. Let's take example and see if this equilibrium or not equilibrium. We have here three forces, 2.5, 1.2 and F. Okay, now in this equation the rod is pivoted. Calculate the magnitude of force required to balance the rod horizontally. So this rod have to be equilibrium or have to be net moment on it have to be 0 or equal moment in clockwise and in anti-clockwise directions. So here we have 2.5 multiplied by the distance, which is 40 centimeter, which is 100 Newton dot centimeter. Okay. In the opposite direction, I have two forces. 1.2 multiplied by 25 centimeter, and the other force, which is unknown, multiplied by 35 centimeters. No need to change the distances from centimeter to meter, because in both sides the unit is centimeter. So you can delete the centimeters together. Okay? Even if you change the units, you will have the same relation. Now we have this value 1.2 multiplied by 2.5 and 0.4 multiplied by 2.5. Take this to the other side, so it's negative, so I can find the value of the force, which is 2 Newton. Okay, center of gravity. We have two things which are center of mass and center of gravity. What is the difference between center of mass and center of gravity? In both cases, we talk about the same thing, which is the point of equilibrium, okay? in center of mass, it is the center of the object. Like, let's say we have a ball. So the center of mass, it is the point where all the mass treated as concentrated upon. This is the center of mass of this ball. What is the center of gravity? It is the point where the force acting on this object. Okay? So we are talking about the same point but in a different way. Okay? So the center of gravity of an object is the point which the whole weight of the object may be considered to act. Again, if we have a man, so the center of mass of the man should be in this region, somewhere in this region. Okay, this is the center of mass. The center of gravity, it is the direction of the force or direction of the weight acting on this object toward the center of the earth. Now again, this is the condition of equilibrium, which are the sum of the forces in any direction must be zero, and the sum of moment of forces about any point must be zero. So the object is in equilibrium. Here we have three forces. We can check if it's equilibrium or not by two ways. You can take the component of each force and check if the total forces upward equal the forces downward and the forces to the right equal the force to the left. This is the first one. The second one, you have to find the moment in clock and anti-clockwise to see if it's equilibrium or not. The other way is to find the resultant force using the triangular method. Okay, we draw first force like this, and the weight, which is the second force, and this is the third force. If the forces produce a closed shape, so this object is in equilibrium. Now, let's talk about density. Density, it is the mass of the object per unit volume. Its unit kilogram per meter cube or a gram per centimeter cube. You can use any of these units to find the density. Now, if we have an object like a cylinder and want to find the density, we find the mass using a balance and the volume depending on the laws. I can find the area of this circle, which is pi r squared, multiply this by the height, so you can find the volume. But you have to change the units to have the same units, like centimeter for both or meter for both, to have the same unit for both sides. Okay, now what is the relation between density and pressure? If we have an object underwater like this, so this object have all of this water over it. Okay, so to find the pressure on this object, the pressure equals force over area. What is the force act on this object? It is the weight of all of this water above this object. So the force equal the weight over area. The weight equals mass multiplied by acceleration of a free fall over area. Okay, now density equals mass over volume. So mass equals density multiplied by volume. Now instead of mass, I can write density multiplied by volume multiplied by gravity and divide by area. Now, what is the volume of this object? It is the area multiplied by this height. Okay, so the volume equals area multiplied by height. Here, this will give us density, area multiplied by height multiplied by gravity. Divide this by area, so you can delete area with area, and you have density, gravity multiplied by height. So the pressure acting on this point, okay, or anything in this point, okay, at this height, the pressure is equal to density multiplied by gravity multiplied by height. And the pressure is measured by using Pascal. The unit is Pascal. Why? Pressure equal density, gravity, height. Density is kilogram per meter cube. Gravity is meters per second squared. Height is meter. Meter with meter. It's omitted with meter cube. So kilogram meter minus 1 S minus 2 second, which is Pascal, or Newton per meter squared. Let's see this example. Pressure, force over area, Newton per meter squared. And the pressure equal density, kilogram per meter cube, multiplied by gravity, multiplied by height. Is right hand side unit equal left hand side unit? It's a must. Let's try. Kilogram multiplied by meter minus 1 S minus 2. On the other side, Newton is mass multiplied by acceleration. Take meter square to the upper side, meter minus 2. So kilogram meter minus 1 S minus 2 have to be equal to this unit. Okay? Now, let's talk about the upthrust again. We say that the upthrust is come because the difference in pressure in 2 points. Okay? So, the reason for this is that immersion in the fluid provides an upthrust or buoyancy force. We have pressure or force from the upper part and force from the lower part. So the buoyant force is the upward force minus the downward force. Okay, this produces a difference in force. Pressure equals force over area. This difference in force multiplied by area, which is the same, so we have a difference in the pressure. Okay, and the buoyant force is known as Archimedes principle. Okay, by this we finish this chapter. See you later, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.